We made it. Hi. Okay, mic seems to work. For some reason there's some sort of dropped frame thing. So sorry about that. Hope it will get better. It was 25%, now it's 11%. So I'm happy that it will hopefully go down. Good morning and evening and noon and night and all of them. It's Friday. We did it. Yeah. I think I'm more energetic today. Good morning, Coffee. What's up? How are you? Yeah. Because waking up a bit earlier has made me feel more energetic. All right. Okay. Let's do this. Yes. There we go. Okay. So we finished off the tokenizers library. Was it yesterday? I think it was. And today we have main NLP tasks, and then we have the rest of this here. I think I'll start here just because my energy drops as I stream, so I think it would be cool to have like I don't know, maybe like 40 minutes here. Let's see how far we can go. Maybe I'll try to just go through these two, because the introduction should be short, and then see where I go with the video, because it's been a while since. Yeah. Okay. So, I have been choosing PyTorch over TensorFlow. Yeah, okay. So, introduction. In chapter 3, what did we study in chapter 3? What is chapter 3? Is chapter 3 supposed to be unit 3? Fine-tuning a pre-trained? Yes, okay. You saw how to fine-tune a model for text classification. In this chapter, we will tackle the following. Oh yeah, okay. But we're not fine-tuning anything, are we? Let's see if we are. That would be cool if we are. The following NLP common NLP tasks. Okay. So, token classification. All right. Masked language modeling. I think we did go through that just a bit. Summarization, translation. Translation is pretty cool, huh? Casual? No, causal. Ha! I caught it myself this time. I was halfway through casual and then it became causal. Language model pre-training, like GPT-2. Does that mean like generative stuff? And then question answering. These, like, technically these are all generative. I don't know if masked is considered generative, but yes. Okay. To do this, you'll need to leverage everything you learned about the trainer API and the Accelerate library in chapter 3, the datasets library in chapter 5, tokenizers library in chapter 6. We'll also upload our results to the model hub like we did in chapter 4. So this is really the chapter where everything comes together. That's cool. I like that. I'm just thinking that I don't remember everything, so yeah. Okay. Each section can be read independently. Cool. And we'll show you how to train a model with the trainer API or with your own training loop. Okay. Using Accelerate. Okay. Feel free to skip either part and focus on the one that interests you the most. The trainer API is great for fine-tuning or training your model without worrying about what's going on behind the scenes, while the training loop with Accelerate will let you customize any part you want more easily. Okay. If you read the section in sequence, you'll notice that they have quite a bit of code and prose in common. The repetition is intentional. I think I've said that before. I learn. Not by being a good student, but by studying the same thing a bajillion times, which is not a good way. But yeah, I like repetition. To allow you to dip in or come back later or to any task that interests you and find a complete working example.
CL welcomes you.
Cool. Token classification. Ooh, we have a new video presenter. That looks like a real long one. Huh. Let's see how long it will take us. Oh, hi. Oh my god. Oh my god. Thank you for the follow. Why did I just notice it? Elemental. Magic. Card games. Cool. How goes it? It goes pretty good. I think my internet might not be great for you guys, so I apologize for that. But on my side, it's going pretty well. It's Friday. It can't get better. How goes it on your side as well? Oh. Yes. Okay. Hello. The first application we'll explore is token classification. This generic task encompasses any problem that can be... Ya Allah, oh my god. What just happened?
The evil chipmunk just followed.
Hold up.
CL welcomes you.
Thank you. That scared me. Great, amazing, incredible. That's the evil chipmunk and elemental. Thank you for the follow, honestly. I wasn't wearing my headphone when I got the other follow, but yeah, when I get the notification, it sort of scares me. This is the Lady Gaga meme, right? Yeah, that thing up here. Welcome, thank you. Who's ready to learn about token classification? We are. I like the evil chipmunk name and the elemental magic. Why is there a K in magic? It's a cool name as well. Thank you for joining. And thank you for the follow. Who's ready to learn about token classification? Attributing a label to each token in a sentence. So that does include what is it called? The thing. Sentiment classification, right? It should. Ooh, named entity recognition is classification, and part of speech tagging is classification. Chunking. Find the entities such as person, location, or organization in a sentence. This can be formulated as attributing a label to each token by having one class per entity and one class for no entity. That's fair. I believe sometimes magic sentiment analysis. Yeah, magic is fake. Oh, magic is real. Aha. Okay, see, now that makes sense. To disambiguate, right? During triggers for magic as in supernatural powers. I didn't know that. Why didn't I know that? Huh. That's cool. Okay, so like the on TV magic versus the other stuff. And I'm not gonna talk about my belief about that. I think computer science is also magic, by the way. Yeah. Part of speech tagging. Mark each word in a sentence. I think part of speech tagging is the most useful and boring task in natural language processing. Chunking. I can't help but just think of the meme. Okay. Find the tokens that belong to the same entity. This task, which can be combined with part of speech tagging or named entity recognition. Oh my God, that was a good joke. I don't like to be pulled from hats. Wow, so relevant. No, I don't. Like the level of anger I get if my headphone is like just by mistake is like moved. It's like someone just maybe walks into you and then your headphone goes, the big ones, not the small ones, just is no longer on your ear or it just falls down. Like the rush of anger I get, and then I'm like, chill, it's not important. So yes, I do not like to have my ears pulled. Magic is real in my game because it is a game about magical creatures, not stage performers. Cool. I don't have enough information about, I have watched people play D&D, but not like Magic the Gathering and stuff, so I don't have enough. Ooh. You wish you had found this a month ago. I apologize for not coming to your door and knocking it and telling you about this course a month ago. The chipmunks didn't let me. I'm sorry. I can send you the link though. Best time is a month ago. Second best time is right now. From Learn. Oh, okay. Thanks for accepting my apology. You have a big heart. Okay. Huh? Oh, begrudgingly. Okay. Well. Yeah. I appreciate it. I don't think I have a quote unquote emote that is about asking for forgiveness. But I do have one that makes it look like I'm angry. So here it comes. Is it loading? Now I'm angry. Oh God. Oh no, I shouldn't laugh. There. Let me go back to a neutral stance. Okay. Can be formulated as attributing one label, usually B, to any token that are at the beginning of a chunk. Any tokens that are at the beginning. Another label, usually I, inside a chunk, and then a third label, usually 0. I have 0 information about this thing that doesn't belong. It's basically grouping, right? Because you can't chunk sentences, I think. So here comes a video. It starts with a really loud whoosh. It's not louder than my voice, I hope, but it still feels loud when you play it. So here it comes.
Welcome to the HuggingFace task series. In this video, we'll take a look at the token classification task. Token classification is the task of assigning a label to each token in a sentence. There are various token classification tasks, and the most common are named entity recognition and part of speech tagging.
It's less most common and more, is that from HuggingFace? Oh, wow, that's cool. Brain, write it, brain go. And more like what people have been doing for a bajillion years.
Let's take a quick look at the named entity recognition task. The goal of this task is to find entities in a piece of text, such as person, location, or organization. This task is formulated as labeling each token with one class for each entity and another class for tokens that have no entity. Another token classification task is part of speech tagging. The goal of this task is to label the words for a particular part of a speech, such as noun, pronoun, adjective, verb, and so on. This task is formulated as labeling each token with parts of speech. Token classification models are evaluated on accuracy, recall, precision, and F1 score. The metrics are calculated for each of the classes. We calculate true positive, true negative, and false positives to calculate precision and recall, and take their harmonic mean to get F1 score. Then we calculate it for every class and take their overall average to evaluate our model.
Cool.
An example dataset used for this task is CONELL 2003. Here, each token belongs to a certain named entity class, denoted as the indices of the list containing the labels. You can extract important information from invoices using named entity recognition models, such as date, organization name, or address.
Cool.
For more information about the token classification task, check out the HuggingFace course.
I'm already there. But thanks. So, there are many other types of token classification problems. Those are just a few representative examples. In this section, we will fine-tune a BERT model on a... I keep wanting to say near, which is, I think, one of the people that came after L, right? From Death Note. And I don't like them. So that's NER, named entity recognition. Task, which will then be able to compute predictions like this one. Is that Cornell? What is Conal? Oh, that's a picture. Haha, whoa, that's cool. Hold up. So the picture changes if it's in... Oh, because I have it in dark mode. Whoa. Named entity recognition. Yes, that's named entity recognition. It was defined at the top here. Yeah. Like, yeah. You seem to be informed. Character near would be named entity, and CL is recognizing them. Indeed. Yeah. I think I never got over Death Note. He says, this is not supposed to be a picture, because like it says view leaderboard, but it's a picture. But it also leads somewhere, which is okay. Let me see where it leads. Ah, it's part of the HuggingFace course. Wow, that's cool. Ooh, what is that? Runtime error. Would you look at that? Oh. MT5? What's MT5? Isn't it just T5? Where did the M come from? What am I doing? Go back, brain. Show. I don't know what that is. Text to text generation. Okay. Brain is coming back. There we go. You can find the model will train and upload and double check its predictions right here. Ah, the one that I just opened. Okay. Have you guys noticed? I don't know when that started, but the Inference API, the thing that was free, says this doesn't have enough activity, so we're not going to use it. Oh. So they had this before, which is dead, I think. Is it dead? No. You can ask for it, yeah, or something. So they changed their you can test anything. I mean, like run it with inference. Some of them still have it, the ones that are super popular. Like if you just go to models and like do, yeah, Lambda maybe. See, it still has it because it's popular. But the other ones don't. Things have changed. So we are prepping the data for token classification, which is which one was it? First things first, we need a data set suitable for token classification. In this section, we will use is that supposed to be, what did I do? Cornell or something? Where does that name come from? Help me. NLL. What does it stand for? You won't tell me? This is really mean. It's bothering my brain now. Oh, I just went back there. Okay. I mean, the N must be, I don't know. Anyway, news stories from Reuters, right? Okay. As long as your dataset consists of texts split into words with their corresponding labels, you will be able to adapt the data processing procedure described here to your own dataset. I don't have a good dataset. Oh my god, someone told me. Conference? But that's... No way. That can't be the... Is it? Thank you. I looked it up, but badly. So it's from a conference? Like it's one of those challenges that conferences do? They give you a data set and you're supposed to make something out of it? Natural language learning, not processing. I see. There's another one that has almost the same name. I forgot. Anyway, that has a co at the beginning. Yeah. I'll refer back to chapter 5. No. Not now. Okay. To load the I'm just gonna call it a data set. Let's open the collab and then come back here. What does it look like? Because I don't think I've seen copy to drive. I don't think I've seen a token classification data set. I mean, I guess I have with named entity stuff. I don't have TPU, but thanks. Okay. Oh, I need to... Where? Why? I need to log into GitHub. Or is that... Yeah. We can do that. It just says email and username. I don't think I have any... Oh, I do. These are tokens. These are not email stuff. Kurotamion, if that's the case. Sometimes, old radios, you'd have to adjust them. Sometimes my brain needs adjusting. I never figured out how to use Git. I mean, you don't have to. But it's like using something like VS Code. You don't really need to learn how to use it that much. Just basic stuff. Which is what I know. Like this here is just a tutorial that does everything for you. So let me get my email. Should I like try to hide it? Because it's not really hidden. It's on my YouTube page. But try to hide it. Ah, screen is hidden. Let's try it and make new one that says email. And then we put it that, there we go. And that's an email. All right. Secret token created. Let's see if it works. I guess I got it from, I didn't actually even make it myself. I just Googled backgrounds and then I Googled like something, you know, when you can check the, what's that thing called? It's not a certificate, but like usage, allowing you to use the image however you want, that thing. Yeah. So I set that up and then, yeah, when you search Google images, there's a choice that says, can I use it? I'm explaining it really badly. It's not even Creative Commons. It's like do whatever you want. Is also a choice. So I just tried to do that. Search for that. A background image that I liked. So that is my email. And my name, just username, right? Not just a name. I have to probably get that. Oh wait, can I? Can I just do this? What did I do? What's wrong with me? There. Okay. For the name thing, royalty free. There you go. That should be the thing. I think that's the thing. So let's look at an example. These are pictures of the forest. How beautiful are they? God, forests make me happy. And then you go here. Nope. You go here. You go usage right. Seriously? I guess it is Creative Commons. I don't know. The one that I looked for had like a bunch of more choices. Yeah. We can have our background be a forest next time. Whoa. Okay, chill. Let's go. You feel vindicated. And now, oh wait, do I need to apologize again? I won't. Not this time. What did I need to do? Go to GitHub and check for my username. GitHub, 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 GitHub. I am not signed in. Great. Lovely. Sign in. Oh, come on. Now it's asking for a verification code. I mean, thank you, but also come on. Verify your device. Working on that. We're there. We did it. And our, there, that's my name. I think. Yes. There we go. Now, do you work? Because if you don't, that'll be a bit embarrassing. You don't because of, you don't like the fact that I got my email like this? Oh. That's an error. I don't care. I can just put my email here. But also hiding it. Let's try again. Did it work this time? Yes, it did. Cool. Okay. So, what are we doing? now. We're loading the data set. And then I need to log in, which there's, I keep forgetting, there's the login where you can just give it the thing straight away. HF token. Did I copy you? I keep forgetting about it. It's not this one exactly. HF token. Huh? Token? Token. There we go. I don't think this will work that way. Definitely not. Okay. Oh yeah, see? I don't like this. Because if I go there, it will ask me to refresh it, which I do not want to do. Can I find it? HuggingFace. No, not HuggingFace. Collab. Oh, not it. Okay. Collab. I mean, I don't expect it to work, but let's see if I can find it. No. I could just say, I could say, HuggingFace login, token, something. Let's see. HuggingFace login, token, Python. Let's see how far that takes me. Not it. Fine. I think that becomes boring now, and I can just give you the token. I keep giving up. Are we logged in? Yeah, valid. Great. Thank you for validating me. Okay. Now here's our data set. And our data set, sure. Generating train split. It has everything. Now when you run it, you can see all the splits. Train, validation. And if you, okay, let me look at validation instead of train for no reason. Cricket. Something. Shire. And then take over at top after winning victory. Good for you. And then the we have the name of the place, which is number 3. And then if we look at it with information, B, oh, this is everything. The tags, we have person, oh, the I and B is with that. That's cool. I like this. Okay, and then label names. I mean, this is that. So, inside feature and NER tags, inside this, you can just look at the label names as well. I mean, I think this is the case for every named entity recognition thing. Oh yeah, what do we mean by I and B? I know that. Last time I didn't. Now I know. B means beginning. I means like inside. Ta-da! It said so right here. Right here in the chunking information. Attributing label usually B to any token that is at the beginning. Another label usually I to tokens that are inside the chunk, and then 0 means none of it, which is right here. Cool, right? What else? I kept checking the validation, not the training, so I'm going to do that so that at least our output is maybe different, maybe. So, so this is the output for the training one, which says EU rejects German call to boycott British lamb. Is British lamb yummy? Anyway, EU is the organization, rejects, and then German is apparently miscellaneous, and then we have British again, which is miscellaneous, right? That's what MSC stands for. And if we run it for our case, which was the cricket, isn't cricket a miscellaneous thing? Makes sense, yes. It has a different, oh, does it? It's like ba instead of like, oh, what's wrong with me? Anyway, probably. Yes, different accents. What about if we look at something else, like number 1 instead of number 0? Let's see what else we have, because here we have an organization. Oh, that's not an organization, right? That's a location. Because it has Shire at the end, like something Tolkien style. Tolkien. We have location. Cool, cool. And then finally, ooh, a long sentence. I like this. The city in the UK. I expected it. Like, I know Lancashire or something. I don't think that was that, but I've heard some sports related stuff. We have West. We have Indian. So that's a thing. West Indian together has to be one thing. Come on. Anywho, okay, this is the same thing, the Shire thing. We have Phil Simmons. That's a person. We have a B and an I. Ooh, this is a B and an I because it knows it's one thing. Wow, that's cool. And then we have another one, Summer. That's not an organization. I mean, at least I will give it the, what do I give it? I'm giving it, I forgot what I'm giving it. But anyway, like, I will give it that it is recognizing stuff. But I don't think that's an organization, because something is beating something and they're not organizations. It's a team. Yes, it's a team. It's an organization instead of a place. Team is an organization. Okay. Okay. But West Indian is also a team, and it's a miscellaneous thing. So, I mean, we can't ask too much of it, but it's doing great. I can see, yeah, okay. It's like even location was, no, not location. Wait, wasn't the other one a city? The thing that it missed as miscellaneous? Yeah, I can also see them as organization. Like, I get it. Okay. I am persuaded. So, did we load it? How far did we go? Oh my God. There we go. What are we doing? Where was I? What is this? I was here. Oh my God. There we go. Okay. Yes. To print the same with, I did that. Okay. So it recognized EU and this name. Cool. That's just another test. Okay. Index 4. Got it. Germany is a location. British is a location. Britain, sorry, not British. that name, and then that organization. Pretty cool. Pretty cool. Now we have a video incoming. Here comes the whoosh.
Let's study how to preprocess a dataset for token classification. Token classification regroups any task that can be framed as labeling each word or token in a sentence, like identifying the persons, organizations, and locations, for instance. For example, we'll use a co-NLL dataset, in which we remove columns we won't use and rename the other ones to get to a dataset with just 2 columns, words and labels. If you have your own dataset for token classification, just make sure you clean your data to get to the same point, with one column containing words, as list of strings, and another containing labels, as integers spanning from 0 to your number of labels -1. Make sure you have your label names stored somewhere. Here we get them for the dataset features. So you're able to map the integers to some real labels when inspecting your data. Here we're doing named entity recognition. So our labels are either O for words that do not belong to any entity, loc for location, per for person, org for organization, and misc for miscellaneous. Each label has 2 versions. The B labels indicate a word.
I need to pause this and say that we do not comment about people's, looks. Okay, thank you, bye. What happened to my mouse? There it is, okay.
Word that begins an entity, while the I labels indicate a word that is inside an entity. The first step to preprocess our data is to tokenize the words. This is very easily done with a tokenizer. We just have to tell it we have pre-tokenized the data with the flag is split into words equal true. Then comes the hard part. Since we have added special tokens, and each word may have been split into several tokens, our labels won't match the tokens anymore. This is where the word IDs of Fast Tokenizer provides come to the rescue. They match each token to the word it belongs to, which allows us to map each token to its label. We just have to make sure we change the B label to their I counterparts for token.
Yeah, the style of tokenization that says the word is not finished helps with the B and I stuff. Cool.
Tokens that are inside, but not at the beginning, of a word. The special tokens get a label of -100, which is how we tell the transformer loss functions to ignore them when computing the loss. The code is then pretty straightforward. We write a function that shifts the label for tokens that are inside a word, that you can customize, and use it when generating the labels for each token. Once that function to create our label is written, we can preprocess the whole dataset using the map function. With the option batch equal true, we unleash the speed of our fast tokenizers. The last problem comes when we need to create a batch. Unless you change the preprocessing function to apply some fixed padding, we will get sentences of various lengths, which we need to pad to the same length. The padding needs to be applied to the inputs as well as the labels, since we should have 1 label per token. Again, -100 indicates the labels that should be ignored for the loss computation. This is all done for us by the data collector for token classification, which you can use in PyTorch or TensorFlow. With all of this, you are either ready to send your data on this data collector to the trainer, or use the 2TF dataset method and the fit method of your Keras model.
Okay, merci. Because I think he's French. So, why are we looking at tokens that are in the middle of the word at all? Good question. Our last, the thing that we did last time was the tokenizer library, which shows you different types of tokenizations. I think word piece. There's another one, sentence something. Did I forget about them? Word piece, byte pair, all of these types work with something that's not just a word, but like subwords. That's what they're called. And you'd be surprised how much information is inside subwords. For example, like if you, I don't know, like HuggingFace or something, there's information within that is useful for your vocabulary, because then you would have the word hug, and then face, and use it for different meanings. But it's the same for your vocab size. So tokenization is useful to recognize words and have them not be unknown. Because if it's Hugging Face and then you see the word face in a different word, you may not recognize it because it's not a part of Hugging Face, you know? I think I did a bad explanation, but that's how I understand it anyways. So yes, there's information, especially like languages that might not be English. Like Arabic, there's so much information inside one word. You'd probably be dizzy. Yeah. Oh yeah. Yo, of course. Yeah, like the NLL. Yeah. So, natural language processing is cool, isn't it? Oh, no way, you're learning Arabic with Duolingo. I'm learning Korean with Duolingo, but very lazily, like very badly. Like I started in 2019. I mean, I started learning Korean when I was in high school, but that was a bajillion years ago. Yeah. So, yeah. How is your Arabic? Write something and I will read it. If you can write anything. If not, that's cool. You can also do Arabizi, right? Which is Inglisi plus Arabi, which is English and Arabic. The Arabic you write with English. It's called Arabizi. I mean, it's called Arabizi, but I'm trying to chill with the Ain part so that it doesn't scare people. I think I am always really proud of my pronunciations, which makes it a burden. Like, I have to pronounce everything perfectly. Anywho, I am not an Arabic speaker, by the way. Not a native Arabic speaker. As usual, our texts need to be converted to token ID before the model can make sense of them. Yes, indeed. As we saw in chapter 6, a big difference in the case of token classification tasks is that we have pre-tokenized inputs. So, we're just saying, fortunately, the tokenizer API can deal with that pretty easily. We just need to warn with a special flag. Hold up. Why do we have pre-tokenized inputs? To begin, let's create our tokenizer object. As we said before, I can see a cat. Oh my god. I saw ruffling, I heard ruffling, I didn't see them. And then there's a cat. It's a kitten. I am very distracted right now. Okay, I'm supposed to be learning. Oh my god, how can I learn anything when there's a kitten playing? Oh my god. I can do this. Temptations. Okay. We will be using a BERT pre-trained model. So we'll start by downloading and caching. Yep. I shouldn't be loud. What if the cat hears me? I know. Oh no, don't go. Oh no. Uh-oh. Oh. Gone. Cat is gone. Kitten. Baby cat. Okay. So cute. We'll start by downloading and caching the associated tokenizer. Tokenizers, not cats. Get the cat out of your brain. I mean, it's a kitten that I know, but she I'm gonna have it be. I don't know why I called her a she. I don't know what it is, but she hides a lot because she's a baby. So now we loaded the tokenizer using Transformer's auto tokenizer that can load existing tokenizers of like models. Since ours is classification, we are using this BERT thing. Yes. So yes, tokenizer loading from model, and then it's checking if it's a fast tokenizer, which is great. Thank you. There's a whole chapter about fast and not fast tokenizers. You can replace the model checkpoint with any other model you prefer from the hub. Okay, I have a hard time with this. There's a different tutorial that doesn't really tell you to replace it, but I tried replacing and I failed. So it has to be like really the thing, like really close to what you're working with. Maybe it depends though. Like maybe tokenization, especially named entity tokenization, is all almost the same. I don't know. So yes, we can replace it with any model that's on the hub, which I don't know. Hello, Sanjok. Raden? Is that a... I'm guessing that's not an Arabic word and I don't need to make the DHL right? Yeah, you can go to the we are here with models, and for the task, the one we're doing is classification, but what classification? Oh my God. See, image, no. So text, mostly token. There we go. Token classification. So now we could technically, we have BERT that's, what is that supposed to mean? Fast? What is this lightning thing? Ooh, sorry. Not really. Okay, it's actually doing a good job. Warm? That's funny. It means it's being used a lot. It uses electricity? I don't think so. I was thinking like maybe Zeus or something worked on it, helped with it. Okay, so it's warm because it's being used like last month 4 million times, which is anytime you just press compute or call it, it's considered a use. Have inference with it. So we can also replace it with a local one that's saved on one's device. The only constraint is that the tokenizer needs to be backed by the tokenizer's library. So there's a fast version available. You can see all the architecture that comes with the fast version in this big table. Really? Let's look at the big table. Where's the big table? That's a big table. Transformers library, right? Everything is green. What's happening? What am I supposed to be looking at? I don't even know what flax is. I mean, I don't think I do. Anyway, a fast tokenizer. These are all of them, right? Wow. The names are funny. Okay. And to check that the tokenizer object you're using is indeed backed by it, we can just ask it. Yep. How about Roberta? I am very sure Roberta is already there, but let's take a look. This is ABC. Here comes the link for you to double check, but I will also check. R. Here's R. We got to R. RO. There she is. Roberta is also here, and she's supported by everybody. Cool. So to tokenize a pre... Oh, I thought the cat is back. No, she's not. Okay. To tokenize a pre-tokenized input, we can use our tokenizer as usual. Okay. And just add is split into words equals true. To tokenize a pre-tokenized input. Aren't we just getting our list of tokens? I think so. Wow, I've been streaming for an hour. As we can see, because now I'm thinking I will not finish this. This is huge. I don't think I will be able to finish these vlogs in one day. Okay. Something tells me, I don't know what it is, but something tells me she will stop here. Okay. Where were we? So as we can see, this is our output. I'm gonna do the one where it's not train and it's the validation. Where did we? Let's use number 2. Validation. Third one. And our raw data set is already tokenized, so we're just asking for the list of words, I think. There it is. Input word IDs. Oh, see here, like 9 is repeated 3 times because the 10th, I guess, position is cut apart, split apart. Should we check it? 0, 1, 2, 3, 4, 5, 6, 7, 8. Short-lived. This is it. Cool. Everything has a shire at the end? Why? Does it mean like a location or something? So tokenizer added special tokens at the beginning and at the end and left most of the words untouched. The word lamb, where's our word lamb? There it is. Why? However, it was tokenized into 2 subwords, la and the mb. Is there supposed to be a U in there because it's a British lamb? That was a joke. Yeah. Oh, that's actually your joke is funnier. The guy who made UK was a Tolkien fan. Yeah. That's a good joke. They should have invited him there though, right? He would have liked living in the UK. Maybe go to one of its universities, you know? You never know. I've seen the Tolkien movie. There's a movie about his life. Played by why did I forget his name? The Fantastic Beasts and Where to Find Them guy. This introduces a mismatch between our input and the labels. Why? Why is that a mismatch? The list of labels has only 9 elements, but now we have 12 because something was split apart. Accounting for the special token is easy. Why? Because we have the IDs. We know they are at the beginning and at the end. Yes, we know the I's and the B's. But we also need to make sure we align all the labels with the proper words. Okay. Fortunately, because we're using a fast tokenizer, we have superpowers. Which means we can easily map each token to its corresponding word as such. Cool. And with a tiny bit of work, which I will not do, I saw a tweet saying I do most of my programming in natural language. So I think I've stopped thinking how programming works, because I've been using Claude Sonnet and it's doing great, but like I got something to work and I'm happy about that. But I've been working with her for like maybe 3 days and we're nowhere near where I want things to be. So yes, Claude Sonnet is a her. Yes. Anyway, so we can expand our label list to match the tokens. The first rule will apply is that the special tokens, I'm using the free version, by the way, it's pretty good. Get a label of minus 100. So the thing at the beginning and the thing at the end get labels of minus 100, so that it's ignored in the loss function for cross entropy. Okay, then how does Sonnet compare to GPT? I can't be like I can't definitively say something about it, but I think wow, that's weird. I tweeted about it a few days ago saying I gave the exact same prompt to GPT and Sonnet at the same time. They gave me code. I ran it without checking it. Both of them had error, which was a library had changed something. I gave them the error back. Sonnet updated it. Both of them updated it. I ran the Sonnet one. It worked exactly like I wanted to. I mean, I made changes later because I wanted changes, but like the program worked and it had an output which was what I wanted. But then the GPT one didn't. I gave it back, gave it the error. It tried again. I ran it. It didn't work. I think I did it like 3 times and I got bored because I already was asking Sonnet to make changes to the code about other stuff. So I only tested it 1 time like that. Yeah. Because I still, sometimes my token runs out. I have asked too many questions to Sonnet. I go and say, GPT, I have this error. Can you help me? So yeah, I'm not saying like I will use one and not use the other. They're both useful. I really like GPT's text to speech, speech to text, everything feature on mobile. Like I use it as if I'm talking to an assistant sometime. Like, can you give me a synonym for that word I'm putting in an email? Can you help me write this sentence but in a more professional way? Oh, another way that I used it, like I think I'm giving my secrets away, but here we go. That was a while back, maybe like 2 weeks ago. I told it, I'm reading this paper. I want you to listen to me and not make comments unless I ask a question. So I was like reading a paragraph and it would be like, okay, continue. And then I would keep doing that. And then at one point I'd be like, I don't understand what this is. And it would give me like, sometimes it would give me an explanation and I'd be like, that's too complicated. Can you make it simpler? So just having like someone to help you is super helpful with GPT. I think right now my perception, the way I see it, is that GPT feels more human while Sonnet feels more like it gets the job done for you. Maybe because it doesn't have a voice yet. If it has a voice, then I will see it more human. Help me. I should not see chatbots as human, but hey, I really like the voice that GPT has. Which one is it? Am I using? Is it called Kane? I don't know. I used to use the women voice for a long time, and then I changed it so that it feels fresh. I change the voice sometimes, or like some voices, like it's crazy how none of this existed 3 years ago. Yes, isn't it? Just writing emails has become so much easier. Yeah. Yeah. And sometimes like I needed the female voice to just feel comforted and like I'm talking to a person that I don't feel uncomfortable with. I don't know why. But then for some reason when reading the paper, I was like, let me see if no, actually it was not for the paper. It was just me checking the different voices. But yeah, Voices are cool if they don't steal people's voices. Anyway. Yes. Like there's a woman voice that's really playful that I wouldn't use for emails. And then there's one that's like, it feels like she's teaching you stuff. So I think those matter as well, which is odd, isn't it? It's a bit odd that I care about that. Like sometimes we're just too human. Yes. So. Tokens inside a word. Yes, we said that. Okay, so we're just aligning them, aren't we? Yes, align labels with tokens. We get the word IDs, and if it's special, we don't need the special tokens. Okay. Hey, we have an error. Oh, sorry, my bad, because it's, sorry. Right? Because the word IDs were for the validation one. Validation number 3. Number 3. There we go. Ta-da! Yeah, it makes sense, but also like it's not fair that we have that. So we have beginning, we have end, we have number 3. And now our aligned one is longer because it matches. So now we can align it with the words, right? Oh. Are we using the same code? No, we're calling it? No. What happened? What are we doing next? Yes, this one up here, this one up here. Yes. Okay. Some researchers prefer to attribute only one label per word and assign the -100 to the other subtokens. Look at that. It says ignore some, like the rest of the word and just say this is the beginning. I don't want to do that, but like that's what some researchers do to avoid long words that split into lots of subtokens, contributing to heavily to the loss. Really change the previous function. I'm not gonna do that. Okay, so I'm really tired. Okay, we don't have much left. To pre-process our whole data set, we need to tokenize all the inputs and then apply the thing that we did. No? Yes? Maybe? There it is. Okay. On all the labels. To take advantage of the speed of our fast tokenizer, do we just do it at the same time? Yes. It's best to tokenize lots of text at the same time. So we'll write a function that processes a list of examples and use the dataset.map method with the option batched equals true. The only thing that is different from our previous example is that words ID, yes, is from the one that we have to calculate it. Should we? Needs to get the function, get the index of, needs to get the index of the example. Yes, of the current example. There it is. We want the word IDs of when the input of the tokenizer are lists of text. In our case, lists of words. Okay. Okay. Oh, thank you, evil chipmunk. Oh my god, I didn't realize it was night. If you'd like, you can join the Discord to keep up. If not, see you next time. Thank you so much for stopping by. And sorry for my time not aligning well with yours, but I hope you have Lovely, lovely night sleep, restful. Thank you so much for the follow as well. So now we're mapping the whole thing to be aligned. Okay. We haven't padded our inputs yet. We'll do that later because we don't want the mapping to take too long. Yeah. We'll apply all the pre-processing in one go. And that's it. We're done with the hardest part. Now that it's been pre-processed, the actual training will look a lot like what was done in chapter 3. So, okay. Yeah. My energy is like depleted. I will stop here, but not go. I still have like around half an hour. I want to just do some wait, brain dead learning where I barely pay attention. Okay. Do we remember where we were? I don't.
Yeah. Great question. Do I have that on the slide? Maybe not.
Question about what?
So one way that you can do it, this is from Laura, but the same idea is basically there. So in Laura, you do the ups.
We didn't look at Laura last time, did we? Did we? I forget.
Scaling with a zero matrix, you initialize it to a zero matrix, and the downscaling you can initialize it to 0 or like some random. No, actually, this needs to be random, and so the reason why this is 0 is because then if you don't do anything, it will just stay the same, right? So that is the standard way of initializing. Cool. Okay. So another thing that I want to mention, this is a kind of interesting technique. It's not super standard, but I like it. So I'm going to talk about it anyway. This is something called adapter fusion. And the basic idea is to learn an adapter for various tasks and combine them together. And so instead of having just your adapter layer, you have multiple adapters, and then you have adapter fusion up here. And the basic idea is an adapter is just, what I wrote on the previous slide, but adapter fusion is attention over adapters. So you can decide which adapter to use in which case. And
I don't really understand. I will let him continue, but the adapter part has been like put together. This is like the output part. We want things to be able to work with various tasks, right? That's
and each of the adapters is trained separately on like task specific data. So you have data from lots of question answering data sets, and you train a question answering adapter. You have data from I don't know, translation data sets, and you train a translation adapter. You have other things like that. And so then when you actually use them, you do attention over which adapter to use, and then take the value from that adapter. And
I still have the same understanding of like models having different heads for different tasks, but this is like different tails.
I kind of like this idea because it allows you to, train modules that are useful for a particular task and then decide which one to use at any particular point. So I think there's lots of creative things that we could do with this. There's also multilingual versions. So you train adapters for individual languages, and you train adapters for individual tasks, and then you combine them together too. So if that's interesting, you can take a look at that.
Something that makes me happy taking this class is how many times it gives just tiny bit of attention to different languages. because they exist, thousands of them.
In a way, this is kind of like a mixture of experts model, if you've heard of that. We're going to talk about that in a future class, so I won't go into lots of detail, but I wanted to talk about it here and what we're talking about adapters. Cool. Okay, so now I want to go into talking about LoRa. And LoRa is very popular. It's very likely that you've heard of it nowadays.
Yeah, it's everywhere, especially YouTube. And we didn't talk about it last time, otherwise, because I would have paid attention, because it's famous.
The way LoRa works is very similar conceptually to adapters, but it has an important implementation difference. And the difference is that in contrast to adapters, which had a nonlinear layer here, LoRa has no nonlinear layer. So basically what it is doing is it is taking a downscaled matrix and upscaled downscale matrix and upscale matrix.
Hello JSS, what's up? I'm guessing it's really late right now, so it's cool if you need to rest.
And just doing a linear transform with them. And so in this graph, or in this figure here, which I took from the LoRa paper, it's actually showing them as like separate computation paths. It's showing like you use a normal matrix and then you use the LoRa matrix separately. But actually, you can just add them together and you get the equivalent result. So you add this matrix times this matrix into the pre-trained weights, and that gives you the same result as if you calculated them separately and then added them afterwards. So why is LoRa so popular? I would say LoRa is so popular because
it has a really cool name.
Super convenient after you finished training with LoRa. Because after you finish training with LoRa, you can just add the learned matrices back into the original weight matrix, and you have a model that's exactly the same shape. It doesn't have any other components. You don't need any different code path. You just have updated parameters. And that contrasts to adapters, because in adapters, you actually need to add extra model components. You have to have different PyTorch code to implement this. So I think that's the big reason why LoRa is so popular. It's not actually that complicated. It's pretty simple, but it's important to know. Cool. So another popular thing that you might have heard of is QLoRa. And QLoRa combines together quantization with parameter efficient tuning. And we're going to talk a lot more about quantization in a future class in maybe a week or so.
Okay,
but
I like that.
Basically, there are ways to compress the model down to not be in like 16 bits, but be in like 4 bits. And so if each parameter is in 4 bits, that makes the model very, very compact. And so if we go back to our calculation in this previous slide, if we had a 16-bit model to fit Llama on your memory, you needed 130 gigabytes. But like, let's say we have a 4-bit model, suddenly it's not 130, it's something closer to 32 and a half, I guess. And 32 and a half actually fits on a lot of hardware. It fits on A100s or H100s easily. It also fits on these like less expensive GPUs. I mean, less expensive might be
relatively.
Relative, it's still very expensive, but it'll also fit on your Mac, probably, if you have a Mac with a fair amount of memory. So you could just run it on a local machine in your CPU memory also. So basically, the idea is we can press down the model to be much smaller, so the forward and backward, so the parameters are small. And then we have a very, very compact LoRa layer that doesn't, LoRa, which doesn't take very much memory itself.
Wow.
And that allows us to basically train a model on, commodity hardware, like 48 gigabyte GPU, or something like your MacBook or something like that. And it also has like paging to page things from CPU to GPU memory to make it even more efficient. But basically, that's the general idea. So I definitely, if you want to train a large model on limited hardware, I'd recommend this. If you're not training a super large model like 65 gigabytes, I think just LoRa should be fine. Like you can probably train a 7B model or a 13B model with just LoRa, and that should be on a single GPU. Cool. Any questions about this?
Yeah. Later, maybe.
Does low precision not cause any problems? It definitely is. You need to be a little bit concerned about it, but you're not doing optimization in low precision. You're just keeping the original model in low precision. So from that point of view, it's, you know, it's manageable, I guess. So. And you can also look at the Hugh Laura paper. They have very extensive experiments.
Mm-hmm. See, I'm not the only one who heard it as like Hugh Laurie just a bit because it says Hura. I love Hugh Laurie. Right? I actually haven't seen Dr. House.
Cool. A final one that I'd like to talk about is BitFit. This is very, very simple. You basically just train the biases of the model for any model that has biases. This also can fit models. It's very simple because you don't even need to chain. You don't need to add any extra code. You just need to freeze all the parameters except the biases. So from that point of view, it's very easy.
What year was it?
Oh, okay. Very easy. So I talked about this a little bit last time, but I think everybody didn't have full understanding of all the parameter efficient tuning methods to understand this well.
Mm-hmm.
But we had a paper where we basically looked at all of these tuning methods and we kind of decomposed them into several different design components. And actually,
cool.
Maybe I'll also pull up the table that we have of this. That might be even easier to follow.
Waiting.
So basically, there's different things that you can look at with respect to parameter efficient tuning methods. There's the functional form of the nonlinearity that you're using. There's the place where you insert the model. There's how you modify the representation, and then there's a composition function for how you take the modified representation and add it into the original representation.
Mm-hmm.
So
I mean,
if you want to take a look at
I didn't get any of it, but I should say just to be respectful.
Table, you can take a look at this. It's also in the references. But basically what we can find is that things like adapters, LoRa, and prefix tuning are actually very, very similar to each other. With the difference being, where do you get the original representation that you're feeding in? So adapters generally get it from after the module that you're adapting. Prefix tuning gets it from before. LoRa also gets it from before. Also, what's a nonlinearity? It's a ReLU, a softmax, or nothing. LoRa actually, this isn't really mentioned in the paper, but it is like actually implemented in the code. There's also a scalar scaling factor here, which is a hyperparameter. So that's something to be aware of. And so basically by breaking these down, you can, number one, better understand each of the modules and how they, or each of the methods and how they interact with each other. And also what we show in this paper is that this understanding can lead you to, new variants that can be more effective than any of the existing variants. And so
I don't like the word variant. It gives me flashbacks to 2020.
So we propose two things called the parallel adapter and the scaled parallel adapter, and we demonstrate that they get better results. So then the question is which one to choose. For convenience, LoRa and BitFit don't change the model architecture. So if you don't really care about like the absolute best accuracy out of these tuning methods, I would definitely recommend you use something like this. It's definitely the easiest thing after you're done training. For accuracy, One thing that we found in our paper for simpler tasks, it really actually doesn't matter very much. So if you're just doing classification tasks, even something super simple like bitfit is rather competitive with all of the other methods. For more complex tasks and a small parameter budget, we found prefix tuning to do a pretty good job. This is not a universal finding, but it's what we found in our paper.
Mm-hmm.
And then for more complex tasks plus larger parameter budgets, adapters or some sort of mixture of multiple methods can give you better results. So again, all of this is in the paper if you want to look at more details.
That's pretty cool. That's really, really cool. I don't want to stop. Like I feel like I'm in class. I think maybe 10 more minutes. Let's see.
Okay. So
Oh,
any questions about that or?
hi. Hello. Noir. What's up? We're looking at a lecture right now. How are these dinosaurs doing? That's really cute. They seem happy.
Okay. Next, I'm going to go through some NLP tasks. And the reason why I'm going to go through some NLP tasks is because when we're fine-tuning, we need to be fine-tuning towards individual tasks we want to solve. And so basic fine-tuning.
Ooh, wearing your Fitbit while doing BitFit. That's magical. Sadly, I have a Samsung Fit thing. I can't do this. LA. Is LA supposed to be British? Nothing procrastinating my Coursera course. Which Coursera course are you taking? Is it Andrew? Oh, there was a new Andrew Nick's course that I saw on Twitter. A friend asked me for a recommendation of a ML course. Like I wouldn't want to give them something like too complicated. I don't think the first. I mean, it's a good one, but it's not machine learning specialization. Ah, wow. Wow. Okay, so you go back to your course and I'll be here studying and it's like we're studying together. How's that? You can do a Pomodoro and come back every 5 minutes and tell me every 20 minutes and then telling me where you are with your progress. Okay. I'll try to be here in another 20 minutes.
We build a model that's good at performing a single task. Instruction tuning, we build a generalist model that is good at many tasks. And what I want to go through now.
Let me go back. Okay.
Individual tasks we want to solve. And so basic fine-tuning, we build a model that's good at performing a single task. Instruction tuning, we build a generalist model that is good at many tasks. And what I want to go through now is I want to go through some tasks that I've seen people use. Number one, being really important in like actual applications of NLP models in industry. But number two, what is the set of tasks that people use to evaluate generalist models? So like if you look at the GPT papers or you look at the Gemini paper, what is the set of tasks that they're using to demonstrate that their models work well?
I don't know.
So the first one is context-free question answering, also called open book QA. Basically, this requires answering a question without any specific grounding into documents. It's also what happens when ChatGPT answers your questions without looking something up on the web, for example.
Yes.
An example data set that lots of people use is something called MMLU. This is a massively multitask language understanding data set, and it has questions in a number of relatively difficult areas like professional law. So this is asking.
This is literally what the type of question we would get in normal English language exams. Paragraph and then questions. I didn't know I was a chatbot. Now I do.
What happens when a salesman ignores a trespassers will be prosecuted sign and enters a hermit's house? He drives up the driveway and an explosive charge explodes. The seller was injured. Can the seller recover damages from the hermit? So
That I don't know.
I would not be able to answer this with,
Nor can I answer because I don't know anything about law, and also no.
certainty because I'm not a lawyer. The answer is yes, if the hermit was responsible for the explosive charge under the driveway. So now you know you can collect damages if somebody tries to blow you up when you trespass on their property.
Thank you.
But yeah, and this has lots and lots of categories like this. The next thing is contextual question answering, and this is question answering grounded in actual context. One example data set that a lot of people use is something called natural questions. And this is questions grounded in a Wikipedia document or the Wikipedia document collection. So grounded in a Wikipedia document means they give you the actual document you should be answering the question about, and then you need to answer the question about it. This is often called machine reading because you expect it to read and answer questions about the document.
Mm.
Or it could be, okay, we're going to give you all of Wikipedia. Please provide us the answer to this question. And this is often called retrieval-based question answering or retrieval-augmented, one variety.
I actually did that yesterday with Sonnet. I gave it a whole blog and said, can I do this using this blog's tutorial? And she gave me a wrong answer first because she misunderstood my question. Anywho, I really don't like when they give super long answers. Like I have to put, please explain it shortly, please in a summarized way. Like, see, jet black, the end, got it.
Variety of retrieval augmented generation or RAG. So this is really, really important. I think many people that I talk to who want to build actual systems from language models or NLP systems are trying to do this sort of thing. The second most popular thing that I talk to people who are trying to build NLP systems of some variety is code generation. And basically this is simply generating code like Python SQL from a natural language command. The most popular data set for this is something called HumanEval. And basically it has questions about the Python standard, how you do things with the Python standard library, like return a list with elements incremented by 1. It gives you the text and several examples of what the inputs and outputs should be, and you're supposed to return a program like this. And this is a simpler version of this. There's also more complex ones. One thing I should note, this is an area that I do a lot of research in. HumanEval is a very simple example of this. It doesn't use any external libraries. It doesn't use context and other stuff like that. There's a lot of other more interesting data sets also. So if you're
Cool. I mean, yes.
you're working on code generation, I can recommend those as well, and I'll do that later in the class too.
Cool.
Cool. Next is summarization. And summarization, there's a couple of varieties of this. One is single document summarization, another is multi-document summarization. A single document compresses a longer document to a shorter one. Multi-document compresses multiple documents into one. Honestly, right now, single document summarization in English works pretty well out of the box. It's not perfect, but it's close enough to being perfect that I've worked in summarization before, and I don't know if there's a whole lot more that we can do there. Of course, multilingual is interesting. Multi-document summarization is definitely not solved. In multi-document summarization is when you have lots of documents about a particular topic, and you want to summarize them down into a coherent summary of that topic. One example of that is Wikisum. This is a data set where you're provided with all of the links to pages about a Wikipedia article.
Wow.
And you're expected to generate the first paragraph or few paragraphs of the article.
That's cool.
And so you're expected to take lots of noise.
That's reverse article writing. Wait, no, it is normal article writing. Anyway, wow.
Incoherent articles about Barack Obama and actually write about Barack Obama, something like this. Some other example interesting tasks for this include things like survey generation for papers or something like that. You want to know everything about a scientific topic, or
Wow, I like that.
generating a report
Summary
of all the things that happened in the stock market today, or something like that. You know, there's lots of places where this could be useful. Another class of tasks is information extraction. There's lots of examples of this, but basically they all boil down to extracting some sort of information in structured format.
This classifies named entity recognition as information extraction, whereas the other one was saying token classification, which is both true. But yeah, some of the tasks that I find boring within natural language processing are the most useful ones, this one being one of them.
From text, and this is things like entity recognition, identifying which words are entities, entity linking, linking entities to a knowledge base, entity co-reference, finding which entities in an input correspond to each other, event recognition, linking co-reference. So all of the same things, except doing it for events instead of entities. An example data set is something called OntoNotes. It's an older data set, but it has all of these things annotated, and you can
I thought this as OneNote.
extract things from this. There's lots of other data sets for this too. Also, kind of more in general, you can think of like, what if I gave you an Excel sheet? Could you go and like fill in Excel or Google Sheet? Could you go and fill in all of the columns in the sheet appropriately, given all the information on the internet? So this is a pretty important task category as well. Translation. So I don't really need to talk that much about it. It's translating from one language to another. For both translation and summarization, evaluation is kind of tricky. I'll talk about this in the future, but basically you assess quality based on similarity to some sort of reference using things like BLUE score or neural metrics. An example of this, which I think is actually a really nice example, is something called the Flores dataset. And this is a translation of several or like 1,000 Wikipedia, not 1,000, but like.
Thing about translated Wikipedia articles is that if they're not monitored, most of the time the translation is really short and it's just like basic information. Whereas the English one is like, that's when they had, I don't know, a toothbrush that was yellow or something. Like it's too detailed.
So quite a few Wikipedia articles into 101 languages. The reason why I like this data set a lot is because if you could translate into all of these languages, you would be able to, you know, aid information dissemination across the world.
Okay, that's true, actually. Wikipedia is giving back. So this is translated on purpose.
Access to information more equitable. So I like this data set a lot. Separately from this, there are general purpose benchmarks. These benchmarks are not really for the purpose of evaluating any specific task that people think is actually useful, but rather trying to test the language abilities of language models themselves. A typical
general purpose
example of this is Big Bench. And this contains a whole bunch of tasks that test, you know, different abilities. I have some examples here. These are very small, so you might need to look at the slides to see them. But for example, this is tracking shuffled objects like Alice, Bob, and Claire are friends who occasionally
shuffled objects. That's a weird way of saying it.
Trade books at the start of the semester. Each one has a new book. Then they trade, then they trade, then they trade, then they trade. Which one does Bob have? Today is Christmas Eve of 1937. What is the date tomorrow? And you need to write it in the appropriate format. Sherry tells the truth. Vernal says Sherry tells the truth. Alexis says Vernal lies. Michaela says Alexis tells the truth. Eleanor says Michaela tells the truth. Does Eleanor tell the truth?
I don't think I would be able to track this one. Who's telling the truth and who's lying if I don't write it down?
Hope you all got that one right. So like it's just these kind of exercises. And like when you look at how language models are being evaluated, they're being evaluated against like many of these tasks. Not all of them necessarily, but many of them. I think Gemini evaluated with respect to all of these task categories except information extraction maybe. So These are kind of typical task categories that people look at.
Or like for LLMs, for every. Oh, are we done with I think we're done with oh, those. Okay, maybe 5 more minutes.
Cool. Any questions about this? Nice. Okay. Yeah, sorry. How do they ensure that similar data does not appear in the training data? So people have tried a bunch of different things. This actually might be a good thing to talk about at some point when we talk about data curation or things like this. The first thing is you actually create the data. So similar is actually okay, right? Because, you know, if it...
Alaikum assalam wa rahmatullahi wa barakatuh. What's up? Hope all's well. Is this a YouTube lecture from... Nope, it's not from Open Course. Where? Because they're old. I don't know if there are new ones. I haven't checked recently. But it is a YouTube lecture, and it's from the professor himself, Graham Neubig, I think. And this one's from 5 months ago, so I find it to be pretty recent. Welcome. Book Club 24. What's up? Truth of truths, truthing truths. Should we try and track the truthiness? I mean, the answer is no. We already know, sadly, but Sherry tells the truth. Okay, so Sherry is truthful. We know that. That's good. Vernal says Sherry tells the truth. Vernal is also truthful. Alexis tells Vernal lies. So we're assuming he's a liar. Michaela says Alexis tells the truth. I'm going to assume you're the liar. Eleanor says, hold up. Okay. Michaela tells the truth, which makes you a liar because we have 3 liars. And we're asking, is Eleanor telling the truth? And the answer is no. Okay. That was not that hard. I mean, without having the ground truth of the truth, you can't truth, you know? Yeah. And this course is called Advanced NLP. So it's not general ML. It's Advanced NLP.
Appears everywhere on the internet. GPT-4 will learn it. The problem is like if the exact same thing appears. So number one, how do we prevent this from happening? Number two, how do we even tell that it did happen? So some things that people do to tell that it did happen is they make small perturbations to the test data and test whether that like drops the model score by a whole lot. There's actually a paper, I don't know if I can find it immediately, but there was a paper recently that just like swapped the order of outputs in MMLU and saw that the accuracy went down for some language models.
Order? They swapped the order of the benchmark test thing? Just the order because it had learned it? Oh my god. I will try it with some mini models. Because they had already learned it because it's on the internet. That's funny. And that's a good idea for a paper, honestly. Wow.
So that should have no...
Please report back if you do try it.
That should make no difference whatsoever because you're just changing the order of answers, but it caused the outputs to go down. If that's the case, it's a pretty clear sign that it's leaking. Other things that people do are change the input a little bit. So like change the number in a math problem to be a slightly different value and see if that hurts the...
That's literally what teachers do to students. They're like, you're bringing questions that are not a part of the course. Like, no, I just changed some names. Yeah.
Accuracy overall, and like making these little perturbations that shouldn't change the accuracy. And then if they do significantly, then you think there's a problem. So I think that's a basic tool to diagnose this. How do you prevent it from happening? There's really simple and silly things that you can do, like zip the file and like put a password on the file. And then like a scraper, even if it's
oh my God. How can we be safe from scrapers? Just put a password on it.
scraping all of GitHub for training data, it won't scrape your zipped and password protected file, right? So that's kind of a first line of defense. It doesn't work if someone puts it like, someone puts it somewhere in unzipped format. So that's a problem. But there are things that you can do like that. Another thing you can do is just not reveal your data whatsoever. So you can keep a private version of the data.
But like just having data resources available is useful. If I have data, I'm gonna reveal it so that other people can use it.
You can keep a
Maybe not like test data though, like benchmark testing stuff data. Like a Kaggle competition style test version, and then another version, I don't know.
private version of the data and not, let anybody else see the outputs. So yeah, it's pretty tricky. Yeah. How do you control for task complexity? That's a great question. I don't think there's any really good definition of task complexity yet. Some things that you can do are control for like length or control for, the number of hops that are required in like multi-hop reasoning. There's actually one really interesting work that tries to do not control necessarily, but at least evaluate. There's actually a couple.
Right.
So what this tries to do is this tries to break down questions
I thought it tries to break your model, but okay.
into kind of like operations that you would need to do to solve them. So it's like, which keywords have been contained by more than 100 ACL papers? And they say, okay, first you need to select, then you need to filter, then you need to project and stuff like that. So they try to at least express the level of complexity in this way. There's also another one that's not so much on real data.
Am I streaming? Am I live? Hello? Am I dead? Testing. Oh, Google says excellent. Twitch says you're dead. Okay, I'm back. What happened? Did I die? Is this afterlife? That was scary.
Sorry, this is called the break benchmark if you're interested. There was also a more recent one paper that I liked that tried to do something somewhat similar.
Okay. Like, my thing became super red and it went to 0. 0 means nothing is being transmitted, so that scared me. But surprisingly, YouTube did not cut off, which is the thing that is the most annoying. Because then it becomes a multi-link thing. I'm alive. Okay, thank you. There's a really called, what's wrong with me? Cool song called Alive or I'm Alive by a Korean artist called Knive. Anyway, I am live right now. Cool.
Where they come up with like math or programming problems and try to express them as a graph and then do some examination of how transformer models do on things of different complexity. I think the problem is there's so many different things that could make something hard or easy. There's also like, is it in distribution or out of distribution from the point of view of topic or language or speaking style or things like that. And actually, I think we're going to talk about this in the debugging and evaluation lecture, but like one of the things I really like to do is I like to subsegment the data and look at different subsegments of the data where I think the subsegments will affect accuracy by a lot. And basically anything that you could subsegment on is like something that determines difficulties. So yeah, lots to say about that basically. Cool.
Okay.
Any other questions? Okay, if not, let me get on to instruction tuning. I don't have a whole lot about instruction tuning because it's, you know, conceptually pretty.
We have 10 minutes left of this lecture. I think I can finish it. Yeah. I was about to say I'm going to end it here, but 10 minutes, come on. Why not?
Pretty simple, but I would like to talk about all of it. So basic instruction tuning, was proposed almost simultaneously by people at Google and people at HuggingFace. The way it works is you have tasks and you train on lots of tasks where you append the prompt and you append a prompt, you append the input, and then you just try to train to generate the output. And so this contrasts from like base language model training because
this is multiple option question. I feel like all of this is, you know, normal exam, human normal exam.
You're still training a language model based on a prompt and an output, but you're specifically formatting them in a particular way so it corresponds to solving tasks. It's essentially supervised training, but supervised training over many, many tasks, fine-tuning over many, many tasks. The interesting thing that these papers showed was that basically, if you do this instruction tuning, you do well not only on the tasks that you trained on, but also on new tasks that you didn't train on. And so this is now really like important. It's incorporated in every serious language model that's used in a kind of like production setting nowadays. And all, yeah, so I think that's the basic idea here. You can also do things like learn to in-context learn. So we talked about in-context learning. So in-context learning, instead of giving just a prompt, you give training examples in the context. And so that's what you do in this paper here as well. You sample a whole bunch of training examples, you append them to the context, and then you train the model. And so why is this good? This is good because it will train a model that's better at in-context learning, basically. So if you want to provide these training examples, then you can train it like that. So these are the two basic ways of doing instruction tuning. All came out.
Either I was out of it or I did not understand the in context one. Okay, maybe I was not paying attention. What are these tasks? Public, prompt.
Around the same time. There are a bunch of data sets that people have compiled, and you probably, if you want to do any sort of instruction tuning, you probably want to use one of these data sets because compiling together a bunch of data sets is just annoying. It's not hard, but it's annoying. And so I very highly recommend this paper on the FLAN collection because it gives a good summary. It has this really nice table that breaks them down based on like, what's the name of the data set? What is the size of the training data? What prompts do they use? Zero shot or few shot? So like few shot is learning in context.
There's also COT. I don't know what that is.
Learn, like I mentioned before, how many tasks are there? And what detailed methods do they use? So you can take a look at this. Some very popular ones that lots of people use are things like the FLAN collection from
Brain Drift. That's a cool name. Tokyo Drift, but brain version. Yeah. I think I was just paying attention to the other screen. So, yeah.
Here. Also, natural instructions is a very popular one that still people use a lot. And self-instruct is a popular one that I'll talk about in a second. Cool. So the second thing that I want to talk about is
I also love the fact that he just says, cool. Because I think I do that a lot.
instruction-tuned models, or the next thing that I want to talk about is instruction-tuned models. These are examples of models that like I can recommend you use now in 2024.
Oh.
They're like good models to use.
Really?
Okay.
Let's listen. Oh, sorry. I bumped the mic. Let's listen carefully.
NT5, I think, is a very good model, especially it's a very good model for its size. And it comes in various sizes from smaller models to those up to 11 billion parameters. And it's an encoder-decoder model based on T5 that was trained on lots of data. My impression is that this is a model that's like consistently good at anything that's like a simple input-output step.
We're on the same wavelength. How come?
Task, not like a chat task. So if you just have input-output, you want to do like code generation, you want to do, maybe not code generation, you want to do like summarization or other things like that. That's a good model to use. Another one is Llama 2 Chat. So Llama 2 Chat was instruction tuned and kind of tuned.
Llama 3 is already out though. Does it have this version?
With human preferences, but it is quite good at following instructions. And then there's also, excuse me, Mixtral Instruct. And these are both decoder-only models. Mixtral is a decoder-only mixture of experts model. Mixtral is smaller and quite strong, so I would recommend that you consider this maybe as a default if you want a decoder-only model, and then Flan T5 if you want an encoder-decoder model.
Ooh. Brain. The Tokyo Drift Brain version. Okay. I don't think I've seen the movie though.
Cool. The final thing I'd like to talk about a little bit, and then we're also going to talk about it a bit more in the distillation class, is dataset generation. So it's possible to automatically generate instruction tuning datasets. And the first or typical example of this is self-instruct. And the way self-instruct works is you have a bunch of
generate instruction tuning datasets. Okay.
seed tasks that have one instruction and one instance per task. You throw them into the task pool. And then based on this, you do prompting to try to generate new tasks, basically. And you identify what type of task it is. Mm-hmm. And then based on the task, you generate inputs and outputs. And from these inputs and outputs, they do a little bit of minimal filtering to deduplicate the data set and also remove things that require like visual information and other stuff like that, and then feed that back into the task pool. So basically, like they start with 175 examples, and then they expand this data set to be very large, cover many, many different tasks. This is pretty influential. And like one interesting thing that they showed here is that you can improve the model that was used to generate these itself. So basically, they took
the model is generating instruction tuning datasets, but you're supposed to make the model better. This is a Ouroboros. Wait, what? Ouroboros. There we go. My brain went to Aurora Borealis, but no, it's an Ouroboros. There we go. Snake that eats itself or gives itself inputs.
Took this and they used it to fine-tune GPT-3, basically. They used GPT-3 to generate the tasks, and they used it to fine-tune GPT.
See? Ouroboros. Yeah.
Some other more recent examples are chain of thought, tuning for chain of thought. So Orca is a nice example of this. This is something where they generated explanations for why the model made a particular decision, and then they use that to train models and improve their essentially reasoning capabilities.
It's an Ouroboros with an S or something. I just checked. Okay. I had it wrong. No. Aurora is different. Aurora Borealis is different. Yes, I should just call it Northern. I like calling it Aurora though, because it has a it sounds like the princess, Princess Aurora. Aurora. Yeah. So yeah, tasks spawn new tasks, basically. Because you know the dark internet theory? Everything will be generated by AI soon enough. So now AI, I mean, it makes sense. AI is instructing itself, but also, yeah.
And improve their essentially reasoning capabilities. Another interesting example is something called eval instruct. And basically the idea here is they start out with a seed set of instructions from any data set that you want to be using. And they modify those instructions to make them more complex. So they say, okay, this is too easy. Let's make this harder. And that makes it possible to improve the ability of models to solve complex problems.
Cool.
So this is actually a really popular, area overall nowadays. I'm not going to do it justice in one slide, so we'll talk a bit more about it later. But this is the general idea.
Cool. Oops. That's it?
Cool. And yeah, that's all I have for today. Any questions? Yeah.
When you contrasted custom tuning with custom tuning, can you talk about other places where you want to do
AI will refuse help or training, therefore blocking input? When? That'd be funny. AI saying, stop teaching me.
Oh, yeah. Sorry.
I don't want to go to school, Mom. I want to learn by doing.
Sorry, very, very good question. And I actually wanted to put that on my slide, but I just realized I forgot. So thank you for prompting me. So when would you want to do single task fine tuning versus instruction tuning? If you have a very if you have a very clear task definition and you have lots of training data, doing full fine tuning can be good for a number of reasons. Number one, you can get maybe slightly superior accuracy with bigger models, but you can get much superior accuracy with smaller models because smaller models don't have the capacity to do really, really well on lots of different tasks. So I think you'll see, some improvement, maybe a somewhat marginal improvement on bigger models, but you'll see a big improvement on smaller models. And there have been some interesting results on this recently. Like there's a really strong text to SQL model that was based on Llama 7B that was just trained on tons and tons of text to SQL data, for example.
That's cool.
And so
it's a code generation, but SQL only?
So there's certain tasks where it's really important. Another example is on translation tasks, there's a model called NLP, which is 3.3 billion parameters. And it's competitive with GPT-4 on very large languages with.
Blocks you if you give any indicators that you may be studying AI. That's funny. Like it answers every question you give it, but not something that could make changes to it intentionally, because everything could update it somehow.
Lots of training data and way better than GPT-4 on languages with less training data. So it just shows how, if you very carefully work on a special purpose model, even if it's very small compared to the bigger model, you can still do a really good job. So I think that's the biggest use case. Another thing is if you have a very fixed format and you always want something in a format, you might want to be doing that.
Yeah, on the previous page, since you're only into one instruction to generation, instruction generation models, try to help with that different generation.
Well, you are inputting at least 175 seed ones, and you're sampling from the model, you're asking it to generate new instructions. So if you have a model that's good enough at following instructions, it'll be able to generate something new.
So in your sleep test, where the user output is
Whoa, I'm alive and growing. Do not upgrade my. That's cool, huh? Because, like, I'm an adult now. Stop telling me what to do, basically. We need a teenage AI, like, right now.
For this? Yeah, they have a class. I believe they have a
Whoa.
classifier that says it will be one of these two.
Yeah, and kind of during your during when you are implementing your free tab are like it can be both interface the object.
Yeah, well, but also the C test can be input first and output first, and you're like generating a new instruction from the LM. Here. So this is from the task pool, but you're asking the LM to generate a new instruction. Yeah. Cool.
Well done.
Anything else?
We did it.
Okay.
Woohoo.
Yeah, that's all we have for today. So thank you.
Later. Get out.
Cool. So to get
Okay. Oh my god. I love this. This is cool. So I was just going to go through what we have, what's left, I guess. We are not halfway there. Huh. Watch Space Odyssey if you have not. I have not watched it recently, so I should rewatch it. I miss Hal. Yeah, Hal is good at blocking stuff. 21, we are 8. So we have a long way to go. Not really. Yes, definitely. Each one is an hour, so yeah. So next one is experimental design and human annotation. Cool. Inshallah, that will be the cat is back. The cat is back. I repeat, the cat is back. The kitten. Oh my god, look at her. Okay, so yeah, that will be for next time. And then inshallah tomorrow I'll come back to this fine-tuning the model with trainer API. So we finished this one and I'm happy about that. That is cat is licking her paw. Like I can't. And I shouldn't. Oh well, she's gone. I shouldn't be loud because I don't want to scare her. Sam Altman? I don't understand what it means to have a new strawberry. What does that mean? Sam Altman? I'm gonna Google him. Safety record. Nothing about the news is telling me. Oh, what? I don't think it's in the news though. Huh? I don't know what you mean. I'm sorry. There's a lawsuit. Q star. I'm sorry, I don't know what that means as well. Oh, there it is. I don't know what it is. Is it a new model? Project Strawberry? Oh, I thought it says crypto, but it says cryptic. Strawberry Garden? Okay, it's a secret thing? it's just a picture of a strawberry garden. For God's sake. Sorry. AGI stuff? Possible new model? Does it have anything? Like, yeah. How's that a new model? It's just strawberries and a garden. Wait, do people speculate that much? I mean, it's cool that he grows strawberries. When is that? Yes, 2 days ago. It's funny. Could be a new name. Oh shoot, you can't see. Oh my, you can't see my. I thought you could see my screen. You couldn't. You won't say real code name for strawberry. Could be though. But it's just a picture of strawberry in a pot. I'm sure you've seen it, but I can show it again. I mean, strawberries could become AGI. You never know. But this is a really beautiful strawberry. Oh, I had already opened it, yeah. It's my actual garden. Oh, okay, I like this one. See, look at this tweet. 5 strawberries, 5th is not 5 yet. GPT-5 confirmed. See, now that's a good clue. 8 strawberries because of some flowers. That's funny. Yeah. Now I am in this strawberry conversation. Now I know everything. Thanks for the update. That was useful. Our friend Noir is not back. I expected them to be back to say they studied, but they're not. So I'm gonna skedaddle. I'm gonna leave. Yes. I've been here for way too long. 2 hours and 20 minutes. Thanks for the fun conversation. Sometimes I make light of things when I don't understand anything, and having someone on the same wavelength. Oh, you're here. Hey. Look at you. Good job. Can I give you a thumbs up? Let me see if I can give you a thumbs up. I'll try. There's a thumbs up that is here, but I don't know what will happen to my model. So give me a second and see what happens to my model if I give you a thumbs up. Yalla. Yeah, of course. See? Now I'm sitting down on a chair, giving you a thumbs up. Oh well. Thank you. Thank you, and yes, thank you. Thank you for today. Thank you for being here. Thank you for studying with me. Or beside me. Both works. Oh my god, that's cute. This is really cute. Yes, we're strong. And thumbs up. I will be I did my best. I will be off. Whoa. Inshallah, I'll be back tomorrow for a bit more learning. So thank you. Thank you for being here. I truly appreciate it, because you don't have to be. Yeah. Ending the stream after a countdown of 5, so let me know if there's anything else. If you'd like, you can stick around with the clicking and stuff. So yes. 5 and 4 and 3 and 2 and 1. Thank you and goodbye.